Hello again. We are back in the world of manipulating radical expressions, and the idea up for bids at the moment is dividing radicals. And there is a little bit going on with dividing radicals, which I don't suppose is a big surprise. But the primary thing to that is utilized in dividing radicals, which is this expression. When you have a quotient of radicals, which is root A over root B, that is equal to the square root of A over B. So you can swap back and forth with radicals, or with quotients, just like you can with products. So with that in mind, then you just proceed and start doing what you're doing, and I will do the simplest kind first because it's probably the most important. When someone says simplify, and this is a test question, for example, and you have something that looks like this: 4 over root 5, and there is like nothing that you can do with that. It's like, well, for sure, this radical in the denominator will not simplify. I can't find a factor of 5 that is a perfect square. And 4 isn't under a radical at all, so I can't even do that with it. But the thing is, when the instruction is to simplify, that means by definition that there is never ever a radical in the denominator. So you got to get that radical in the denominator out of there, and it's called rationalizing the denominator. Rationalize. R-A-T. I don't even know how ration. R-A-T-I-O-N-A-L-I-Z-E. I think the denominator. At the moment, the square root of 5 is an irrational number. No ifs, ands, or buts about it. So we've got to get that irrational number out of the denominator. So what one does in a situation like this, to rationalize the denominator, you use the idea from multiplying radicals that says the square root of x times the square root of x is x. So what I'm going to do is just manipulate this as if I were manipulating a fraction, only I'm going to use this idea. So I'm going to multiply top and bottom by root 5. And in so doing, the denominator now becomes the square root of 5 times the square root of 5 is 5. And upstairs there is 4 root 5, and so now in the denominator is a rational number. It's no longer irrational, and we are done. There you go, one each. Rational denominator rationalized. Oh, yummy. Decaf again. Let's see, let's not save that one. Let's open that one, and let's do another one. Let's see, how about root 4 over 5 root 3? And so there's a bunch of ways you can do this one. I'm hoping what you see immediately is the numerator right there has a perfect square under a radical, which the square root of 4 is 2. And we can do that. We can do that right off the bat. We don't have to, but we can, so I'm going to say, okay, I'm just going to take this term and simplify the numerator and say the square root of 4 is 2, and in the denominator is 5 root 3. Now we've broken a rule. We're simplified, but we've broken a rule in simplification because there's a radical in the denominator, so I got to get rid of it. At least I got to get the radical out of the denominator. So I'm just going to use the same old trick, and I'm going to multiply top and bottom by root 3. and in so doing, root 3 times root 3 is 3. So in the denominator, root 3 times root 3 is 3, and that 5 is still there. So there's 5 times 3, and upstairs is 2 root 3, which then is equal to 2 root 3 is 2 root 3, and downstairs 5 times 3 is 15, and we are done. Not so bad, it says here in fine print. What have I got otherwise? How about the square root of 15 over the square root of 20? What can you do with a mess like that? So I think what I'll do, there's a couple of ways to approach this one, is I'm just going to put 15 over 20 under the same radical, and then I'm going to reduce the fraction in there, 15 over 20. And 15 over 20 reduces to, let's see, they're both divisible by 5, so that would be 3 over 4. 5 times 15. 5 times 3 is 15, and 5 times 4 is 20. Yes? Yes. So now I'm going to just break it back up. Square root of 3 over the square root of 4. Just use this property of that property of quotients, where I took the radical over the whole thing, and then I've got the square root of 3 over the square root of 4, which is root 3 over 2, because the square root of 3 is the square root of 3 and the square root of 4 is 2, and we're done. Square root of 8 over the square root of 100. Alright, this one's a perfect square. This one's pretty handy. So I'm just going to say right off the bat that is equal to the square root of 8 over 10, because the square root of 100 is 10. And then I'm going to fool around and see if I can simplify this square root of 8, and that one will, because it is the square root of 4 times 2 over 10. We could have done this another way. I don't think it's going to work any better than this way, but we could have done it another way, which is equal to the square root of 4 is 2, and the square root of 2 is the square root of 2. That would be 2 root 2 over 10, and that will reduce right there. That 2 over 10 will reduce, and left upstairs is root 2, and 2 goes into 2 once, and 2 goes into 10 5 times, and that would be root 2 over 5. And that's about all I've got in dividing radicals. So the thing to remember in dividing radicals is that you can take a quotient of radicals, root x over root y, and write it as root x over y, where both the fraction is under one radical, or you can write it like this, whichever one is the handiest for what you're trying to accomplish with the problem. And keep in mind that when the instruction is to simplify, that there is never a radical in the denominator. That is not considered simplified because there is an irrational number in the denominator. So if there's a test question, and it doesn't matter what kind of a test question is, or a worksheet question, or any question, and it says simplify anytime, any place, anywhere, and there's a radical there, and it ends up with the radical in the denominator, it won't be completely simplified, so there will be points taken away. So rationalize the denominator always. And with that, we are done. Take care then. Bye-bye now.